Hey kids, welcome to the show. Today I'm going to go over something that I've seen come up a lot of times, which is how to get numbers out of an alphanumeric string. So, first of all, what we're going to do is we're going to look at how you would do that just using worksheet formulas. So I've got that looked up right here on the internet, and look at this beast of a formula. My God. Let's see what that looks like. So I'm just going to paste this in here. Look how long that is. Takes up 2 whole rows. Uh-oh. What do we have going on here? A little bit of extra space. Alright. So you can see it works, which is cool, but good lord, let's see how it works. I'm going to do Alt-MV and just step through this. If you look, each one of these times I'm clicking and you see it changing is another step that this formula has to go through in order just to get the numbers out of this string. So I'm not really going to go over what it's actually doing for the most part, but there are a lot of different things going on here. You can see what it's doing if we get to a certain point here is, so we're going to get an array from 1 to 10, so numbers 1 to 10. And we're going to multiply those numbers once it finds whether they are numbers in the string or not. So it's 10 to the row of 1 to 10. Look at this. So you're doing 10 to the 1, 10 to the 2, 10 to all the way up to 10 to the 10, and then you're dividing that by 10, and then you're multiplying it by these numbers in this string here. It's an insane formula. I don't like doing that because just looking at that formula hurts my head. So let's take a look at a few different ways that we can do this using Visual Basic. So I'm going to hit Alt F11 to get into the Visual Basic editor. I hit Alt IM to insert a new module, or you can do it from the toolbar up here. So let's see just a simple loop, how that would look. So we're going to say function looper. It's going to take s as a string argument, and we'll return it as a string. And we're just going to say, let's dim c as a string. We'll just have that as a thing to hold each letter as we go through it. We're going to say for I is equal to 1 to the length of the string. We'll say c is equal to mid string at position I, 1 character, and then we'll just say if is numeric c, can't type, if is numeric c, then we'll say looper is equal to looper and c. That should be about it. So let's see if it works. And we'll just drag this down. Hey, it works. Cool. Not my favorite way of doing it, but like I said, it works. Let's look at a different way. This is going to be using regular expressions. Now to do this, we're going to use some late binding to use the regular expression library, but even though I think regular expressions are really cool, if you use this on a large scale, especially in a UDF, a custom function like this, it can get really slow. If you do it all in one batch subroutine, you can speed it up a bit. I just think regular expressions are really cool, so we'll look at how that works. So we'll say function, we'll call it reg for regular expression. It'll take s as a string, and we'll return it as a string. And we'll just say with create object VB script dot regular expression. We'll say dot pattern is equal to, and we're just going to, let's see, we want to look for digits, but we don't want, we're trying to extract digits. So what we really want to do is we want to look for the opposite of digits. And we can do that by using that little caret character. So Let's try that. That should work. And then we'll say reg is equal to dot replace s, and we'll replace it with blank. And we'll just say end with, and we'll see if that works. I'm not sure. So we'll say equals reg, go over. So it's doing something, but that's not what we wanted it to do. Let's take a look here. I have to need a plus here. Let's also do global. We'll set global equal to true. Let's see what that does. Hey, that did it. So I think it was just changing it to being global that worked. But there we go. Same results, different way of doing it. We'll go back. And that's the regular expression one. But I saved the best for last. So those are both fine, but I like to do things with speed in mind. Like I said, creating that object and using, importing that library for every time you call the function can get really slow. So this one's going to focus on speed. So let's see how we can do that. So we're going to say this function is called byte array because we're going to be using byte arrays. And we'll say, again, s as a string, and we'll return it as a string. So we'll say BA is equal to as byte. So the parentheses make it an array, and we're giving it a type of a byte. And we'll just say BA is equal to S. That's going to load our string into the array, but it's not going to load the actual letters. It's going to load their ASCII numbers that correspond to each letter, or character, because we're isolating the numbers, right? So the other thing we're going to need is another byte array so that we can store those things into our result. So we'll say dim res as another byte array. And the way byte arrays work too is when you load the string into the array, if the string is 5 characters long, the array is going to be 10 characters long because each character is followed by a 0. So if the letter A corresponds to 65, it's going to be 65 0, then 45 0 in that pattern. So we'll say our result is going to be that, and we're going to give it a dimension of redim res 0 to ubound BA. All right. And we can also, no, I don't think we need to do that. So let's just start going through it. So for I is equal to 0 to ubound BA. But like I said, every character is followed by a 0, so we don't want to go through one by one. We want to skip one every time, so we'll say step 2. So now, what we need to do is kind of figure out where all these things lie. So if we do a little formula here, we can say equals car row. So that's going to give us the character for each row number. And if we drag this down, we'll be able to see what numbers correspond to numbers. There we go. So between 48 and 57 are where the numbers are. Oh, let me scroll up there. Between 48 and 57. So let's go back. So I'm going to say if BAI, and actually let's do this in a different variable. We'll say dim B as byte, and we'll say B is equal to BAI. That way we don't have to keep referring to the thing in the array. We just have that variable ready to use easily. So we can say if BA is greater than 47 and, or not BA, B. If B is greater than 47 and B is less than 59, is that what it was? Let's see. Greater than 47, less than 58. Less than 58. Then what are we going to do? Oh, we need another thing too. We need a counter or a position. So we'll say dim pos as byte. And we'll say pos is equal to 0. And you'll see why here in a second. So we'll say if it is greater than 47 and it's less than 58, meaning that it's a number, then we want to put it into our new array. So we're going to say res pos is equal to b, and res pos plus 1 is equal to 0. And then all we need to do is say byte array is equal to our byte array. So let's see if that works. I'm going to delete that, and we're going to insert our new formula. Okay, that didn't work. So let's take a look and see what's happening. I'm going to go back here, and I'm going to... Oh, I'm returning the original byte array. Maybe if I returned our actual result... Well, it's closer. Oh, you know why? I've got this position variable here, but I'm not incrementing it. So let's say pos is equal to pos plus 2. Let's see what that does. There we go. Now we're using byte arrays. We don't have to do any of those really expensive kind of formulas like mid and left and in string. Those are really slow formulas. Typically, working with strings is a very slow thing when you're talking about coding and speed. Doing it this way, loading it up into an array. First of all, loading up anything into array in VBA is a good way to go. You're loading it into memory, and it's going to be blazing fast doing it that way. And the fact that we're just dealing with numbers and not actual letters and characters and strings, it's going to speed it up a whole lot. And I really think it's cool how I can have an array here and just assign it a string, and it automatically loads it up. I don't have to do anything to go from a string to a byte array. And likewise, I don't have to do anything to go from a byte array back into a string. All I've done is say that I want to return a string, and we're saying that the byte array formula is just equal to another byte array. Don't have to do any conversions. It's super slick and fast. So I hope you enjoyed this video. Hope you learned something. If you have any questions, please leave them in the comments, and we'll see you in the next video. Thanks for watching. Bye.